says an electron and a proton are separated by 2 nanometers. So I'm just going to sketch this out as I do it. So I have an electron and a proton, and they are separated by 2 nanometers. 2 times 10 to the negative 9, right? What is the magnitude of force on the electron? So part A, so what is the force on the electron? And then part B, what is the net force on the system? And so I suppose we should probably label a few things on this. First and foremost, we're probably going to use Coulomb's law, which says that the force is equal to the constant K of charge 1 and charge 2 by the distance between them, or radius squared, or over that. Remember that K is the constant of 9.00 times 10 to the 9. That the charge of an electron, right, is going to be, the charge of the electron is equal to 1.6 times 10 to the negative 19. The charge of a proton is equal to 1.6 times 10 to the 19. And then the distance between the two is 2 nanometers, or 2 times 10 to the negative 9 meters. And so for that one, I could just write it like this. I could say, I just plug the numbers in really. I think I'm going to say 9 times 10 to the 9th, and I'm gonna toss out, I'm not going to write down all the units. 1.6 times 10 to the negative 19 times itself, so it'd be squared, all over 2 times 10 to the negative 9. And so if I'll move this down a little bit, it's kind of in the way. If I plug that in a calculator, let me double check, it should be about 5.8 times 10. Oh, this has to be squared. I forgot to write the square down. Times 10 to the negative 11 newtons. Okay? Because remember, that's a force. Then for part B, it says, what is the net force on the system? Well, the net force, remember that the charge can be positive or negative. And so this will have a negative charge that's equal in magnitude to this charge, which is positive. So they're opposites. So the net force then overall should be 0. Yeah, but one's negative and one's positive. Okay. Well, technically we would say because they are internal forces of the system.